Previously on Virtual Math with Mr. Ferrara. Chords. Just watch the video. It's Virtual Math with Mr. Ferrara. Oh hey, I didn't see you there. I was just about to get started with our geometry lesson. Today's lesson is 10.4, Inscribed Angles. Print out the PowerPoint and work the problems with me. All right, let's get started. Hey, what's up everybody? Today we're going to be talking about section 10.4, Inscribed Angles. If you have a circle and you draw two chords so that they meet at a common point, that's your vertex. The angle created is an inscribed angle. An inscribed angle is an angle made by two chords whose vertex is on the angle. In the picture to the left, angle ABC is an example of an inscribed angle. Also created is an intercepted arc. An intercepted arc is the arc created by an inscribed angle. In this picture, arc AC would be considered an intercepted arc. It's also measured in degrees just like angles are. There's a formula that goes along with intercepted arcs and inscribed angles. The formula is that the arc is twice as big as the angle that creates it. So in this picture, angle B is half the size of arc AC. The inscribed angle is always half the size of the intercepted arc. So example 1, we have an inscribed angle example. They want us to find angle B and arc A. Why don't you take a couple seconds, pause the video, and see how you could work out this problem. Then we'll compare answers. All right, hopefully you worked out this problem. Let's see how we do. So I noticed that angle PQT is made by chord PQ and made by chord TQ. I like to trace the chords to visualize where the arcs are that are created. So PQT is 60 degrees. Immediately I know inscribed angles are always half the size of the intercepted arc. A is the intercepted arc, so A is double 60 degrees or 120 degrees. It becomes a lot easier when you trace out the chords. Now for B, I'm going to trace out these chords and they go up this way and they go out this way. A is part of it, which is 120 degrees. TS is given, which is 30 degrees. I now notice that arc PS is 150 degrees, and that arc is the intercepted arc that's made by this inscribed angle. The arc is always double the size of the angle, so immediately I know now that B is half of 150 degrees, or in other words, 75 degrees. There are several corollaries that go along with inscribed angles. A corollary is an extension to a theorem. Corollary number 1 says that two inscribed angles that intercept the same arc are congruent. Looking at the picture below, angle A creates arc BC. Angle D also creates arc BC. Since angle A and angle D create arc BC, they are therefore congruent. If you look at an example, if angle A was 50 degrees, the arc is double the size, which would make it 100. If the arc is 100, the angle is half the size, which would make angle D 50. If angle A is 50 degrees and angle D is 50 degrees, both of those angles are congruent because they created the same arc. Corollary number 2 says that an angle inscribed into a semicircle is a right angle. If you look at the two chords, those two chords create a diameter a diameter is 180 degrees, and half of 180 degrees would be 90 degrees. Corollary number 3 is one of the more important corollaries. It says the opposite angles of a quadrilateral that's inscribed into a circle are supplementary. Angle 1 and angle 3 are opposite of each other, so therefore added up would equal 180 degrees. Angle 4 and angle 2 are on opposite sides, so they would create 180 degrees. Now this makes sense because if I drew in a diameter, angle 3 creates the arc seen above, angle 1 creates the arc seen below. Together, those two arcs create the entire circle. The entire circle is 360 degrees, and inscribed angles are always half. So half of 360 would be the 180 degrees circled below. The final inscribed angle fact that we need to know is when an inscribed angle is formed by a tangent and a chord. AE is a tangent. Reminder, a tangent is a line that touches the circle at exactly one point. BA is a chord that touches the point of tangency. The arc that's created is twice the size of the angle that creates it. Again, the arc that's created is twice the size as the angle that creates it. So the formula in this picture would be that the measure of angle BAE equals half the arc BDA. If you wanted a numerical problem, if the arc was 220 degrees, if arc BDA was 220 degrees, the angle BAE would be 110 degrees because the arc is always twice the size of an inscribed angle. The next several examples are going to use the corollaries that we just talked about. Pause the video here, try the problem, see how you do, then we'll go over them together. Hopefully you had some time to work over these problems. Let's take a look at them and compare answers. So example 2 wants us to find angles E and angle F, given that DG is 40 degrees. Again, I like to trace out the inscribed angles. So I'm going to trace out DE and GE, and I noticed that 40 degrees was created by a 20 degree angle. So angle E is 20 degrees. I then can trace arc DG by chords DF and GF. They also make a 40 degree arc, which means angle F is also 20 degrees, using corollary number 1 that we spoke about in the notes. Example number 3 wants us to find arc BDA, knowing that angle BA is 100 degrees. This angle is 100 degrees. And we know that inscribed angles are always half the arc that they create. So if this is 100 degrees, the arc that's created is 200 degrees. Hopefully that was an easier example. Let's move on to example 4. So example 4 has a quadrilateral inscribed within a circle. Remembering the corollaries from our notes, a quadrilateral has opposite angles that are supplementary when it's inscribed within a circle. So that helps us find C and D. So if C is opposite from 98, the supplement to 98 is 82 degrees. So that gives us C, 82 degrees. D is opposite from 124, and the supplement to 124 is 56 degrees. So the angles we can find right away. The arcs are a little bit more complicated, so I'm just going to start filling in what I know, and I'm going to use what I know to find what I don't know. So if this angle is 98 degrees, that's an inscribed angle. That means the intercepted arc is double 98 degrees. So when I double 98 degrees, I get 196. But that 196 takes up the 91 as well. So 196 with the 91 removed leaves me this top arc to be 105 degrees. Now I know that didn't help us right away, but it will help us along the line. So I'm going to look at this arc going out this way now from here to here. That's 124 degrees, which means the arc from this point all the way around to this point is double 124, or 248. But that also doubles up with the 91. So 248 minus 91 leaves me 157 degrees. Arc A is 157 degrees. Now to find B, I know that a circle has 360 degrees in it. 105 is the arc from here to here. 91 goes from here to here. And 157 goes from here to here. The only thing not included is B. Add up 105, 91, and 157, you get 353 degrees. I need 360 for a circle, so that leaves me 7 degrees for B. Example 5 I called just a whole mess problem because it's got a bunch of chords, a bunch of inscribed angles, and a bunch of intercepted arcs. It's got a lot going on, so let's focus in on each part of it. First, we want to find the measure of angle A. Angle A creates the arc BD. So if BD is 74 degrees, trace it in. That means angle A is half of that arc, or 37 degrees. Arc CE is made by chord CB and chord EB. The angle is 21 degrees. The angle is always half the arc, so that means the arc is 42 degrees, double 21. Angle C is right here. Angle C makes the arc of 74 degrees when you look and trace it out. 74 degrees is going to be double the angle, so half of 74 is 37 degrees. Angle D goes out towards C and goes out towards A and makes an 80-degree arc. Half of 80 degrees is 40 degrees. And the last one is angle ABE. So ABE creates arc ACE. ACE is the combination of 80 degrees and 42 degrees. So that arc is 122 degrees. The angle is always half the arc. So if the arc is 122 degrees, the angle is 61 degrees. Again, a whole mess of numbers there. Follow the chords to help you find the intercepted arcs and the inscribed angles. Problem number 6 is our last example, and again, it's just another mess of angles and chords. So they give me 52 degrees here, and they give me 88 degrees here. So let's use that to find the missing A, B, and C's. A is going out with a chord this way, and a chord that way. Those two chords create the 52-degree arc, and I know that the arc is always double the angle. So half of 52 degrees gives me 26 degrees. To find B, B is going from here to here. B is the remainder of this semicircle. If 52 degrees is already taken up from a semicircle is 180 degrees. 180 minus 52 leaves me 128 degrees. The arc is always double the angle, so half of 128 leaves me 64 degrees for the angle. And finally, we're at C. C is a little bit easier than that one. C just goes out with these two chords, creates an 88-degree arc, so half of 88 is 44 degrees. These will be a lot easier if you print them out, use a highlighter, and highlight the lines and chords. It makes it a lot easier to see the arcs and the angles. If you have any questions on today's assignment, please feel free to Schoology message me, email me, call the Google helpline, or ask your questions during our next live conference. Till next time, bye.